This entire cement factory has been visualized using artificial intelligence. Every machine, movement, and process you see is AI generated. Cement is the foundation of modern buildings and infrastructure. Yet very few people understand how cement is actually made. The process begins deep inside massive limestone quarries. Limestone is the main raw material used in cement production. Powerful excavators break huge rock formations into smaller pieces. Dust fills the air as heavy machines operate continuously. Precision mining is critical for cement quality and strength. Conveyor belts transport raw limestone across vast industrial areas. Each piece of stone is carefully selected for processing. AI recreates the scale and complexity of real mining operations. This stage defines the chemical foundation of cement. Raw materials must meet strict industrial standards. Even small variations can affect the final product. Mining operations run non-stop to meet global demand. Cement production supports cities, roads, and bridges worldwide. Without limestone, cement manufacturing would not exist. Once extracted, the stone moves toward the factory. This marks the beginning of the industrial transformation. The limestone now enters the crushing section of the factory. Giant industrial crushers reduce rocks into smaller fragments. Mechanical force breaks stone with incredible precision. Dust and vibration dominate this intense environment. Crushed material moves along high-speed conveyor belts. The stone is ground further into fine raw powder. Grinding mills rotate continuously under heavy loads. Clay and iron ore are added to the mixture. This combination determines cement composition and quality. AI visualizes the exact industrial workflow. Every particle size matters in cement chemistry. Grinding ensures uniform texture and consistency. Sensors and systems monitor the process continuously. Errors at this stage can weaken cement strength. Precision engineering controls every movement. The raw mix must be perfectly balanced. Industrial noise dominates this production zone. Massive machines operate with relentless efficiency. The prepared mix now moves upward in the factory. It is ready for extreme heat processing. The raw mix enters the towering preheater structure. This vertical system uses rising hot gases. Heat slowly removes moisture from the material. Temperature increases gradually at each stage. Cyclones spin the material inside steel chambers. This process improves energy efficiency. Fuel consumption is reduced significantly. Preheating prepares the mix for the kiln. AI recreates complex thermal flow patterns. Pipes and ducts channel hot air upward. Industrial design maximizes heat recovery. This step lowers environmental impact. Proper preheating prevents thermal shock. The material becomes chemically active. Now it moves toward the heart of the factory. This is the heart of cement production, the rotary kiln. The kiln is a massive rotating steel cylinder. Temperatures rise above 1400 degrees Celsius. Flames burn continuously inside the kiln. The raw mix undergoes intense chemical reactions. Minerals melt and recombine under extreme heat. The material slowly transforms into clinker. Kiln rotation ensures even heat distribution. Firelight illuminates the industrial interior. Heat waves shimmer through the air. This stage defines cement strength and durability. Every second inside the kiln matters. AI captures the intensity of this environment. Industrial safety systems monitor temperatures constantly. The kiln operates 24 hours a day. Molten textures glow deep orange. Chemical bonds permanently change. The hot clinker enters the cooling section. Powerful air blowers reduce temperature rapidly. Steam rises as heat escapes the material. Cooling stabilizes chemical structure. Proper cooling improves cement quality. Rapid temperature control prevents damage. Industrial fans operate at full capacity. AI shows thermal energy dissipation clearly. Cooling also recovers reusable heat. This energy supports other factory systems. The clinker hardens into solid nodules. Color shifts from red to dark gray. Clinker is crushed into fine powder. Gypsum is added to control setting time. Grinding determines cement smoothness. Particle size affects cement performance. Mills operate with extreme precision. AI visualizes powder flow in detail. This stage creates usable cement. Fine particles ensure structural strength. The grinding process is closely monitored. Consistency is essential at this stage. Cement quality testing occurs continuously. Finished cement moves to storage silos. Packaging preparation begins. Finished cement is stored in tall silos. Automated machines fill bags precisely. Conveyor belts transport cement bags. Robotic systems stack products efficiently. Warehouses prepare shipments for delivery. Cement travels worldwide for construction. Artificial intelligence reveals industrial complexity. Subscribe for more AI-generated factory simulations.